Today, I'm going to show you how you can create paths or roads for your game or any other project in Pathfinding. In this case, I'll be using Odin with Raylib to show you how it's done, but should be able to implement it in whatever language or engine you have, because I'll be going through the code. So let's say you're giving a terrain like seen here, which is a simplex noise generator. Each cell has a different value, and we can see that based on the color. So the in simplex noise slash Perlin noise either generates from -1 to 1. And -1 we can consider as low terrain, so like the water, and 1 we consider very high terrain, like a mountain. So how would we generate a road from one point to another point on this kind of terrain? Well, it's really easy. We got to think of the optimal path. So we can just use a pathfinder. Why don't we find the optimal path based on the terrain and its height value? Obviously, we wouldn't want to generate on a mountain. That's too high. We would want to try and generate on very flat terrain, something that's ideal, maybe something closer to 0. Luckily for us, A-star pathfinding is simple and versatile and works for us. What the benefit of it is that it allows for negative weighted graphs. And so that means each cell has a value, and as we know with noise, it ranges from -1 to 1. Some pathfinders don't even support weighted graphs like jump point search, which I've implemented before. That one does not take into account weighted, so we didn't use that. And others only support positive weighted graphs, which we could still use if we were to change the value to absolute to only positive. So we could change the -1 to 1 or just 0, and then the 1 would now become a 2, so it would be increased. So we could do that and change this, and we will look at those later. Just a quick summary of how A-star works. You essentially go to each cell. Each cell has a starting cost. You then calculate the distance from the end point, and if it's further away, then we can start ignoring it from the previous point. And so that means you're only traversing your path close to it, rather than the traditional Dijkstra's or breadth first search where you would just check all cells. You would even go behind. So for example, this 0, you would also check behind here. Even though it's going further away, you know that's just not the optimal path. You go this way. The only change we need to make to this algorithm is heuristics. We'll just add the noise value in. When we add the noise value in, it looks like this. There we go. There's our path. So we're from one point to the end point. We notice that it could just take a straight line because there's no walls blocking it from doing so. But because we add the noise value, it's going for the negative ones. It's preferring the negative values. So anything that's dark is closer to -1. Anything that's very white is 1, so that would be considered mountains. And this is pretty good. The only disadvantage is -1 is also associated with water commonly, and we probably want to avoid that. So our path's really not necessarily generating for a flattish terrain. It's kind of focusing on lower terrain, and you wouldn't really, or you would build in a valley, for example, you wouldn't be building in water or bridges all over it. So we kind of want to make it so it's sort of like midway, let's say, but you could have this. It really depends. You can customize it however you want. Let me just show you a bit of the A-star code, but rather than just show you the examples. It's a normal typical A-star algorithm as seen. This is the ones from Geeks of Geeks. I've just poured it over to Odin. I made no modifications to it, and so I won't go into it. But here, when we do get the heuristics, I'm just passing in its grid size, the current cell, because it's a noise value, and we can take that into account. And if we look at where it is unblocked, for example, so I'm just checking -1. Well, first of all, we could add some just restrictions. So, for example, if it's greater than 0.5, it's considered blocked. If it's less than -0.5, we also consider it blocked. We can also return the absolute value, like I said, which converts them to -1s from to their positive values. And so that would treat the -1 as well as a value to ignore. So anything closer to 0 is the most ideal value. First, let's just try it with the limitations of the -0.5 and the -5. When we now generate it, results are still very similar, but we're now ignoring the very dark blacks, and didn't really affect the height of values because it was so favored in the dark values that it never really actually got close to it. But we are getting a bit better now, and as you can see, this is a very interesting path we have here already. If your world does not have any water or low level, this is perfectly fine. This is perfectly great. We've got a nice path that you could imagine going through a valley where there's a ton of thick mountains, like in the Alps or something. Now, if we return the absolute value, so no -1s, because -1 would technically make the distance shorter, therefore make it preferred approach. We now get this approach, which is more closer to 0, where it prefers a 0. It prefers, let's say, flat land. Now, when we imagine the very white bits are the mountains and black are the water, therefore we want to avoid them and go for the 0, and as you can see, it goes nicely around them. It's getting pretty good now. This grayscale is a bit boring and uninteresting. Let's have a better way of visualizing. Let's add some color first. So if anything is less than -0.5, we will set to blue. If it's blue, we can imagine it as water. -0.5 to 0, well, we can imagine that as yellow as sand. 0 to 0.5 is green, and anything above that we assume is grey, like a mountain. So now when we run it, we'll get something like this. It's pretty good. There we go. Now it looks like a bit of terrain. Let's also just mess around a bit and change some of the values in our noise map. So I have a frequency, a cell size and all that, and we could, if for example, increase the cell size and see what this results. So make it more larger like this, so we can imagine it as a closer up, like we're zooming in closer and there's a small segment and we have a much larger biome. Or we can increase the frequency, for example, and get some more jagged and messier noise to see how it looks as well, and find our preferred generator. Let's take it a step further and make it look even better with a tile map texture that I've got here, that is from this person, Blue Carrot 16, that I've used before, and all these links will be in the description below. Now when we run it, it looks like this. Ooh, now we're looking better. Now it's starting to look like an actual game. We got lovely water, we got lovely mountains, we got lovely grass. Let's add our path is still red. We need to make it also fit in, so let's add that to the tile map texture. So let's append this path to the world map, so it will generate a path that's not just a red line, that will also fit the texture. If you're wondering how I'm actually doing all this tile map, this rendering of it, and how I can do it like an auto tiler, I do actually have a whole tutorial for this called with marching squares. Go and watch that if you also want to learn how to implement that as well into your game. Now when we run it, let's see how it looks when we add this texture. It doesn't look too great, does it? In fact, it looks a bit splodgy. Our path also just looks very skinny and not really a path, more of a side wall, not even that, and you can fit one person in. We need to modify that even further, and in fact the way it's diagonals doesn't look too great. First of all, let's limit the movement the way the A-star algorithm path finds. We're taking in the corner pieces as well, when we can actually limit it to only left, right, up and down. So when we limit it like this and then we run it, it will make more straight and flat paths. And as you can see, now we're only going left, right, and so now this path kind of looks more organic in this kind of video game world, this RPG-like world. And so widening the path is also really simple. I have a function as well that we just do. It's a simple widen path. It's very primitive and perhaps not the ideal way, as we create duplicate values. I'm not really checking if they're duplicate or not. I just left it as it was. And that is, we simply loop through and we get the adjacent paths, we check each corner and we just check if they're valid and then they're not blocked, and we simply append those values to the path and we return that path. So now when we run the path and edit the world, we will now get a nice thick path like this. There we go, look at that. Now we're looking so much better. You can see in this water bit, we have like almost a bridge in fact, and that we're ignoring it. And so you get really nice effects. So this looks way more organic in the world that we've made. And look, nice lovely flat paths going through. This can make for an awesome dungeon crawler game. You know, you're going through and you got a path and the player needs to go from A to B and you got to fight monsters really well. Oh, it'd be very cool like that. Let's just take it one step even further by adding trees and grass and rocks to our world, so that when we now generate it, we'll get what I showed you at the start, like this. Doesn't that look beautiful? We have lily pads in the water, we have a small grass tufts in the dirt, proper trees and bushes in the grass area, and we have rocks and debris and stuff like that in the mountain area. Now it looks like a proper RPG game. It's looking great. You can obviously normalize the noise value, so when I generate a noise map, I can also just set it, so if it's less than 0.5, just normalize it to -1. Because it's kind of like a tile map based world, it doesn't really make sense to have it be semi value, because it's either a water tile, dirt, or grass, so I should probably just represent it in that. Otherwise you get an instance where the path kind of deviates to the right or something, like it's, even though it could just go in a straight line, but that's because the noise value is like a bit better, so therefore technically that's the shorter path. Technically when it does heuristics, it's technically less. So for example, if I just re-enable the diagonal movement and remove it where those noise values were being like standardized or normalized, we notice that in this, you can see that at the bottom here that it goes up, right, and then goes back in. It doesn't really make sense. If we were to re-add the widen path, it would look better, but because again we're dealing with those tile maps, you might not want them. But if you are having something where the terrain is like 3D, then it would make more sense to probably have this not be normalized. But there you go, that's how you actually generate a path. Now, I'm going to look more deeper into the code and just go through it step by step. So firstly, because I'm doing Raylib, I just set up the Raylib details. I'm going to give it a generate a map by giving it the height and width, and that function is up here as we saw earlier. In this case, we go through each by X and Y, generate noise, get the noise value for that X and Y, normalize it, and also update the level, which is a global array I have stored in the tile map file here. So we can see level, which is a bunch of tile elements, in this case road, water, dirt, grass, and rock. Now back in here, we can add the grid size, another global well, actually sorry, not a global variable, a local variable, and we're returning that array with its noise value. Once we have the map generated, we obviously then want to create the path, and creating the path is really simple. I'm just choosing a random start and a random end, and I keep looping through until I get a good position. Obviously, in this case, it's a bit sloppy because there is a chance that none of the positions are viable, and therefore it will be in an endless for loop, causing the program to crash. But it's just for an example. Feed that start and end position to the A-star Pathfinder, as we see here. It's your typical A-star Pathfinder, like I said, but just make sure you get the noise value and calculate it however you want it. You can get the absolute or just normal value depending on your situation. Customize it however you like. Once we have a path, you could optionally widen the path, and it's really simple. You can obviously make it more dynamic so it doesn't do it in certain so on and forth, but in this case, just simply pick each side anywhere and just increase it. If it's a ballad tile, increase it. That's it. Really simple. And really, that's it. That's the whole thing. You've made your path of that. You can handle it however you want, however you render it. I'm using Raylib, so obviously I just do it the Raylib way, low background and render the foliage. I have all that stuff handled. And so if you really want to view this code, it will be in the description. I have it publicly available, and there'll be different branches for each stage. So the first stage is as it was very simply at the start of the video. The second stage was with a tile set, and the third stage is with also the plants and decoration added to it on top. So if you enjoyed that tutorial video and found it helpful, then do please subscribe to my channel, as I do more videos on this program tool, and I do like to specialize in procedural generation. I do have way more planned for that and more tutorials, especially in Odin and Raylib. So stay subscribed if you want to see more. See ya.